All right, I'm trying to get these answers to you, kids. So I'm in the truck. If you hear it raining or whatever. Here we go. What is the average acceleration of the object from 0 to 8 seconds? Well, there's a formula. Acceleration's equal to your change in velocity over time. The original velocity is 0, and at 8 seconds, the velocity is 8. So the change in velocity was 8 meters per second. How much time went by? 8 seconds. So the average change was 1 meter per second. Okay? How far has this object gone in 12 seconds? We're going to go here to this 12. And we know that the area under the line on a velocity over time graph is equal to the distance traveled. So we have triangles, square, and a rectangle. Let's see, this triangle is 2 by 8. So 1/2 of 16 is 8. This triangle is 2 by 4. So that's 8. 1/2 of that is 4. This is a square that goes from 2 to 10. So this is 8 by 8. So that's 64. And then this is a little rectangle that is 2 by 4. So that's 8. So the area under this line is 8 plus 64. That's 72, 80, 84. 84 meters. Two cars are in a race. One travels at 13 meters per second. That's its velocity times its time. And the other is traveling at 9 meters per second, but has a 4 meter head start. So it's going to have its velocity times time plus an initial distance. So this is y equals mx plus b. So 13 and 9 plus 4. We can say, hey, 13 times t is equal to 9t plus 4. If I'm going too fast for you here, there's another video called the double line graph video you can always look at. We're going to solve for our time. 13t minus 9t gives me 4t. 4t is equal to 4. T is equal to 1. T is equal to 1. So say it's going to catch that in 1 second. 1 second. All right. That seems about right. It's going to catch it in 1 second. Draw a qualitative graph of the race. The graph will be like this. This guy's got a head start, and this guy's going to catch it. Does that make sense? This is the second car. This is the car with the head start. After the car starts, how many seconds will it be? 1 second. How far down the track will a collision occur? Well, this car travels at 13 meters per second. So 13 times 1 second equals 13 meters down the track. That's when the track crash is going to be. Number 6 and 7. A car accelerates from 0 to 12 in 6 seconds. Graph this below. Okay, here's velocity. Here's 0. And we're going to make this 2, 4, 6, 8, 10, 12. And it's going to do it in 6 seconds. 1, 2, 3, 4, 5, 6. So we can say this. 0, boom. That's exactly what the graph would look like. Now, graph this below using numbers on the graph. All right, the distance graph we can get from here. The area under this line is going to show us how far it went. 6 times 12 is 72. The area of this is 36. Now my pen's running out. Hang on, kids. There we go. So the area under here is 36 meters. So it's going to go like this. And its distance is 36 meters. We're going to have a nice smooth curve here. And this could be 6 seconds if we wanted to add all that to it. Okay. Number 8. A skater rolls 44 meters for a distance of 244 meters at 2 meters per second. He comes to a slight decline and accelerates, then hits a wall and stops. So what was his maximum velocity? How far did he skate total? Well, this skate total is going to be xf is equal to xi plus vit plus 1/2 at squared. Now look, what was a little different about this problem is skater rolls across the distance for 204. So you're already given xi. You don't even have to figure that out. So xi is 244. Now, this part of the problem is our acceleration problem. 2 meters per second is his initial velocity, and the time on the acceleration is 17. So this is 2 times 17, or 34, plus 1/2 the acceleration. He comes to a decline, so he's going downhill, so he's speeding up. He accelerates at 0.11 for 17. So 1/2 0.11 times 17 squared. So I can't do that in my head. So I'm going to say 0.11 times 0.5 times 17 squared